Hey everybody, so in this video what we're going to do is we're going to talk about the notes from Cycle09A, so the first start of Cycle 9. We're talking about functions and relations and how we can, how a function is a relation, but a relation isn't necessarily a function. We're going to talk about evaluating and then reading domain versus range. So if you have any questions, please let me know, and we're going to start right away. So, all right, here we go. So we're going to start off first by evaluating functions. And when we talk about evaluating functions, we're finding an f of x is a function of x. So we're seeing domain and range or input and output at the same exact time. So you can see down below here that the x value is considered our input for our output of f of x. Now, you'll also see that this is actually our y value. So when we start talking about slope-intercept form, so y equals mx plus b, y is our f of x. So we can substitute those in and out. What it does allow us to do is see the input and the output at the same exact time, rather than seeing here's x, here's y, here's f of x equals, and we see the input and output simultaneously. So to find a value such as f of 5, so we're inserting this 5, we're plugging it in for x, and we're using the substitution property. And then we just go ahead and evaluate whatever the function is equal to, and we move on from there. So in our first example, and I'm going to only do a couple of these, but to start off, we have f of x is equal to x squared plus 2x minus 5. F of 4, so again our x is equal to 4 in this case. We have 4 squared plus 2 times 4 minus 5. So anywhere that we saw an x up in the original function, I'm going to insert this 4. Now one thing that I don't have written here, which I am going to add, is make sure you use parentheses. Now it's not going to matter when you deal with positive numbers, but when you deal with negatives, you got to make sure that you do that, especially when you have exponents. So we end up getting f of 4 is equal to 19. So we see the input for the output right away. Then in this next function, let's go ahead and evaluate this one. So this one is going to be going to give us a fraction, but that's okay. Okay, so what we're going to do, oh no, it's not. We're plugging it back into the original. Brings me to a good point. F is the function that we're using. Don't use it in the g function. We are plugging in negative 5 for every x in our f of x function. So f of negative 5 is equal to 1/2, I'm sorry, I just did it again, parentheses, negative 5 squared plus 2 times, parentheses, negative 5 minus 5. So we're going to go ahead and evaluate. So what we have here is negative 5 squared is really like saying negative 5 times negative 5, which is a positive 25. And if you do it in your calculator and forget the parentheses, it will give you a negative 25 in return. So use parentheses. Make sure you do. Then we have minus this 10 and then minus 5. So 25 minus 10 and then minus another 5 ends up getting us a value of 10. So we have f of negative 5 is equal to 10. That's function notation. Okay? So big key here is use parentheses when you're substituting in. Now, in the next section, we're going to ramp this up a little bit more. So instead of just evaluating one function, we're going to evaluate multiple functions at the same time. These are called composite functions. And composite functions are just a combination. A combination of functions. So combining more than one function. Okay? And evaluate each function below. And the big thing here is that you want to start on the inside and work your way out. So inside, out. So what we're doing here is, so this f of g of 2 function, we start with the g of 2. So forget about the f altogether. If we forget about the f altogether, we just have this g of 2. So that's what I'm going to evaluate first. So g of 2 is equal to, I find the g function, which is up here, 4x minus 5. I'm going to plug in 2 for x. So 4 times 2 minus 5. Again, I inserted this 2 for the x. I'm going to evaluate. 4 times 2 is 8, minus 5 is 3. So now my g of 2 is equal to 3, but I want to evaluate the f function for whatever g of 2 is equal to. So I'm going to take this now, and this is my new input value for my f function. So I'm going to take this 3, and I'm going to plug it into my f. So now I evaluate f of 3. F of 3 is negative 5 times 3. Okay, I'm going to take whatever my f function is, which is negative 5x. I'm going to multiply by 3, and I end up getting negative 15. So my final solution is f of g of 2 is equal to negative 15. And that's my function. Okay. Likewise, when you go to evaluate again, you start from the inside, so I'll do one more here. So h of 5, we find h of 5 first, so we have 5, let me write that here, h of 5 is equal to 5 squared plus 3 times 5. That's equal to 25 plus 15, which is equal to 40. And then I'm going to evaluate the g function because it's in the outside. It's my next function to evaluate for. So then I do g, let's do g of 40 is equal to negative, 4 times 40 minus 5. Okay, so 4 times 40 is 160, so 155 is your answer. 155. So our final solution is h of g, that's backwards. G of h of 5 is equal to 155. So you work your way inside out, solve the inside function first, and then plug it in for your solution for the next problem. Okay, so what we're going to do now is graphing linear functions. And feel free to pause this video at any time if I move too fast, or if you have any questions, you can certainly ask the person who's in the room here. So to graph any functions, we can make a table of values, and plot the points in the table. So we're just going to do one of these, and I am going to make a suggestion for your domain. So because we can see the entire graph here, I would recommend doing both sides of the y-intercept so we can see the entire graph, not just part of it. So I like to start with a -2, -1, 0, 1, 2. It gives a nice balanced look to when you go and graph those points. And what we're going to do is we're going to evaluate each function for x. So f of x, when x is equal to -2, I'm going to plug it in. So this would be f of -2 is equal to -2 times -2, which in this case is 4. So you don't have to write out every single one, but if you wanted to, you certainly can. So -1 is the next point that I'm going to evaluate for. So I plug that in, -2 times -1, and this gives us 2, then a 0, and then a -2, and then -4. So I can go ahead and plot. Each one of these are points, by the way. So we just have ordered pairs that are points. So we have -2, comma 4, -2, 1, 2, 3, 4, and then we have -1, 2, 0, 1, -2, and 1, -4. And then you can draw your very crooked line there through the equation. Okay, so you evaluate each part of the function. Okay, we have one more portion here. So using graphs to problem solve here, so we're going to look at this as the input and the output, so our x and then our y, which remember, we can always consider the output being the y value as well. Graphs of functions may be used to represent data. Points in the graph of a function represent the input and output values. So if we are finding the input is x, the output is y, or in this case, f of x is the output. We can find each one of those corresponding to the graph. So if you take a look down here, so we're using a scale of 1, and here we have this equation. So what is the y value, or the range, or the output when x is equal to 4? So I'm going to find x is equal to 4. 1, 2, 3, 4. I want to see where this intersects this line at x is equal to 4. And it intersects right here at this point. Okay, and that point is 1, 2, 3, 4, comma 2. So this is 4, comma 2. The y value when x is equal to 4 is 2. Okay, what is the y value when x is equal to -6? So I'm going to find -6. 1, 2, 3, 4, 5, 6. And I'm going to evaluate 1, 2, 3, 4, 5, 6, 7. So 7 is the y value at -6, comma 7. So this would be y equals 7. So we're just trying to find the corresponding output for the input that's given. What's the x value? So now we're going to reverse this. I'm going to find my y equals 2, 1, 2, and I'm going to find where this line would intersect. So 1, 2, 3, 4. And it looks like we got the same one as up here, so x is equal to 4. Okay, and then the last one here, what is the x value when y is equal to 10? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to I keep going over, so we have y is equal to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And unfortunately, it goes off the line here, which is okay, because that brings us to a good point. So if we could write that, the equation to this line, we can actually find points that are off the graph, and that's called extrapolation. So if there's my y-intercept. My y-intercept is 1, 2, 3, 4, 0, comma 4. So I'm going to write y equals mx plus b. So I know that my b is 4. X's stay the same, and then we have a slope of negative 1/2. So negative 1/2 equals y. So when I know my y is equal to 10, I can substitute in. So this is a bonus question here that I was not anticipating. So 10 is equal to negative 1/2 x plus 4. I'm going to subtract 4, and we get 6 equals negative 1/2 x. When I divide by negative 1/2 x, my x is equal to negative 12. Okay? So, didn't anticipate that one, but when you can't see it on the graph, you can always find the equation of the line and plot the point. Okay, one other one here. Let's go ahead and do function A only. Function B will let go. So function A, when f of 2. So this means the x value is 2. 1, 2. I got to find function A, which is here. Okay, and if I count up 1, 2, 3, 4, 5, 6. So this is 2, comma 6 at this point. So the f of 2 is equal to 6. The y value, or the output, or the range of that point is 6. Find f of 6 using function A. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it looks like this is 6, comma 10. So 10 is my output. As you can see, it shows the ordered pairs. 2, comma 6, 6, comma 10. That's why function notation is nice. Okay, so that's about it. As you can see, you have a practice exercise the next in your workbook. If you have any questions, please let me know. Peace.